Okay, what we're doing today is we're going to start by learning about the Pythagorean theorem. Okay, so let's highlight this first. So the Pythagorean theorem is probably one of the most known math theorems or formulas you'll have. When I ask kids to say a formula, a lot of times I get y equals mx plus b, e equals mc squared, and then this is the third one I get, which is a squared plus b squared equals c squared. Pythagorean theorems work on right triangles. Okay? And so here's my right triangle. This is my right angle. The side that is the most important is this hypotenuse right here. The hypotenuse is the longest side, and it's also the side that's opposite the right angle. So the right angle points at it. This is C, which is your hypotenuse. The other two sides are your legs, and it really doesn't matter which leg it is, if it's A or if it's B. All that matters is the hypotenuse has to be C. And so when I do this, let's draw a picture. Let's say I have 7, 10, and I need to solve this. This is my height, and so it equals my height squared. The other legs, you also square them, so 7 squared plus 10 squared, and so 49 plus 100. 49 plus 100 is 149. And then to get rid of a square, this might be new to some of you, or you haven't done it in a while. To get rid of a square, we take a square root. So you can leave it as the square root of 149, or you could type it in the calculator. And the square root of 149 is 12.2. And some teachers will ask you to break it down. I'm asking you to leave it either right here or right here. Either of those answers are acceptable. Okay, what we're going to do now is do some more examples. So the first thing I want to do is I want to help you set up. And so the hypotenuse, again, is opposite the right angle. So there's my hypotenuse. So what I'd like you to do is I'd like you to try and write the equation. So when you think you have it, go ahead and press play. Okay, so you should have had equals 24 squared, and then my legs are x squared and 15 squared. Now this one looks different than our previous one up here, because our previous one, our hypotenuse was the x. But we're still just going to do our math. So it's going to be x squared plus 225, because 15 squared is 225. And then 24 squared is 576. Now to get rid of a plus 225, we're going to subtract it. And so 576 minus 225 is 351. And to get rid of a square, I square root it. So the answer is the square root of 351. Or if you want to find that decimal, square root of 351 is 18.7. So either of those answers are acceptable. Okay? I'd like you to try number 2 on your own. Set it up, figure out which one's the hypotenuse, set it up and try and solve. When you think you have it, press play again. Okay, welcome back. You should have known the hypotenuse was this 15. And so it's going to be equals to 15 squared. So x squared plus 12 squared. So that's x squared plus 144 equals 225. I'm going to minus 144. And then 225. Hold on. My tablet. 225 minus 144 is 81. Uh-oh, what's going on? And so now to get rid of a square, I'm going to square root it. And square root of 81, I don't want you to leave that way. You should recognize that the square root of 81 is 9. And so when you have a perfect number, I want you to find that perfect number. Okay, last one. Same idea. I'd like you to see if you could figure out what's the hypotenuse. Which one do you think is the hypotenuse? Yeah, this is my right angle right here, so this is my hypotenuse. So I know that it has to equal x squared. Well, I have this leg here, but I don't know what this one is. Well, good. If you recognize this is a rectangle, if the top's 18, the bottom's 18. Okay, so I'd like you to try that, and when you think you have it, go ahead and press play. All right, so you should have gotten my pencil 49 plus 324 equals x squared. 49 plus 324 is 373. And then when I take the square root of 373, I get 19.3. So x is equal to the square root of 373, or x is equal to 19.3. Either of those are acceptable. So it's not that difficult of a process, but the most important thing first is to figure out where your hypotenuse is. It's not always going to be x. Sometimes your x is a leg, so you have to be careful with that. All right, let's go back and look at notes. Okay, so you had the vocabulary word of a Pythagorean triple, but let's just remember, it's the sides of a right triangle with no decimals. So you can't have decimals. So common one is 3, 4, and 5, because that's 3 squared plus 4 squared, which is 5 squared, which is 9 plus 16 equals 25, which gives us 25 equals 25. So that's a triple because they're equal and they're whole numbers. Now, there's something interesting that happens with triples. If I multiply all these numbers by 2 and get 6, 8, and 10, it also is a triple. So 6 squared plus 8 squared is 10 squared. So 36 plus 64 is 100, and 100 equals 100. So if you can recognize this basic one, 3, 4, 5, and then recognize when things are multiples, you can know that they're triples. And that just helps save time, especially when you have to solve for x. Some people will recognize it and do it right away. Some people may not recognize it. But if you can recognize it, that's awesome. All right, another common one. Go to another set, is 5, 12, and 13. So 5 squared plus 12 squared is equal to 13 squared, which is 100 plus 144. I'm sorry, I don't know why I said 100. Go back and fix that. 25 plus 144 is 169. And that is true. And it has that same process. So if I decided to multiply each of these by 3, so I get 15, 36, and 39, it actually works also. So I don't know these numbers squared, so I'm going to get my calculator real quick. I know 15 squared is 225. Oops, didn't mean to make that smaller. And then 36 squared is 1296. 39 squared is 1521. And I bet if I add those two all together on the left, they give us 1521, because again, it's a triple. So this is another important triple to recognize. If you can recognize those triples, it may save you time down the road. Okay? All right, let's see. Oh, I keep making this smaller. Okay, the last thing we have to do is do the converse of it, which again we talked about in our vocabulary, so you might already understand it. But it can be the Pythagorean theorem can be used to determine the type of triangle formed given the number of sides. So if it's a right triangle, it's a squared plus b squared equals c squared. If it's an obtuse triangle, c squared is big. So that's bigger than the other two numbers combined. Because remember, obtuse triangles are open past 90 degrees. Okay? If it's an acute triangle, it's small. And so a squared plus b squared is actually bigger than c squared. So if you focus on the hypotenuse and it's squared, it'll help you figure it out. All right, let's do some examples. So determine if it's a triangle. Well, first we have to do that. And remember, determine if something's a triangle. I'm always going to kind of underline my hypotenuse. I need to check, is 7 plus 10 bigger than 15? Yeah, it is. So now I can do my Pythagorean theorem. I don't write a sign here because I don't know what's going on. 7 squared plus 10 squared is 149. And 15 squared is 225. So this is big. It's bigger, so it's obtuse. Okay, so my biggest side would be 10. So I have to check again, is 5 plus 8 bigger than 10? Yeah, it is. So now I'm going to do 5 squared plus 8 squared and 10 squared. So 5 squared is 25, plus 8 squared is 89. I'm sorry, plus 8 squared. Those two together make 89. This is my hypotenuse, which is also bigger than 89, so again, it's obtuse. Okay, what I'd like you to do is try number 6, 7, and 8, doing that same process. First of all, determine which one would be the hypotenuse, and see if it forms a triangle. And if it forms a triangle, then you go ahead and go on to the next part. Okay, so for number 6, you should have found out that this was your hypotenuse. And we check to see if it's a triangle. Is 5 plus 7 greater than 13? No, it's not. So this is not a triangle. This is an important part, because if you continued on, you would find that it's either obtuse or acute. But it's not a triangle. You first have to determine whether or not it is. And this one is not, because the two sides are not bigger than the third side. So let's look at this one. My biggest side is 20. So is 12 plus 16 greater than 20? It is. So now we can do our Pythagorean theorem and see what's going on. Okay, so 12 squared plus 16 squared is 400. And 20 squared is 400. Oh, so these are equal. So this is a right triangle. That's another triple right there. 12, 16, 20 is a triple. All right, let's look at this last one. Okay, here's my hypotenuse. Is 4.5 plus 4.5 greater than 8? And it is, because 4.5 plus 4.5 is 9. So now I'm going to square them. Okay, so 4.5 squared plus 4.5 squared is 40.5. And 8 squared is 64. My hypotenuse is big, so it's obtuse. If you notice you didn't get any acute, you do get an acute one, but they're harder to create, and so somehow you just got all obtuse. But remember, the most important thing, again, I could say of everything out of these lessons, is that you have to identify the hypotenuse. Once you identify the hypotenuse, you can go on and solve the problem from there.